Yes, welcome to SkyTour LiveStream tonight. This is Marc Antonio, as always, and I am here. It's 10:30 here, but it's only 7:30 out in the desert, so it's not quite dark yet, hence the screen with only one little star poking through right here. All right, so we have a little bit to go here, and we have to do a plate solve to help the telescope find its place. And I wanted to just mention, as usual, you have me, but we also have Daryl Mason. Hello there, Daryl. How are you? And welcome to the fun show.
Hello, Marc. Thank you. I'm good. You too, I hope. Hello, everybody.
I am good, thank you. We just have to wait for everybody to say that they're fine and they're dandy and all that stuff. You know, I want to say hello to Anahata77. Hi there, Bonnie. How are you? I want to say hello to JSCO77, who's here. And we have Daisy and Zoe Amethyst. We have Arliss Ray. Hello there, Arliss. Nice to see you here. Judy McClelland, welcome once again. It's good to see you. And we have Vera Lucia Campos from Brazil. Zadarak is here with us tonight. And then we also have one more person that I think... Oh, and Papa Tom is here. Hey, Papa Tom. Nice to see you. And CND Boy was here earlier. Donald Kunzer was here earlier. Hopefully he's still out there in the chat. And I want to give a special welcome to Drexy BTW. Drexy BTW is actually a relative of mine. He's a young kid who's actually does a lot of work for... veterans. He does scoops for the troops, and he is he's making a name for himself, and I'm really proud of him, and I just want that to be publicly known here on this stream. So let's all welcome Drexy. His name is Michael.
Hello, Michael.
Oh, look at that. Hey, indeed. So, oh yes, and by the way, it is Easter weekend, so why are we streaming on Easter weekend? I don't know, because it's a full moon and I won't be able to do it tomorrow. So there you go. So we're going to stream tonight. That's okay, Drexy. Drexy says, thanks for the big plug. That's okay. Not a worry. Not a worry. You earned it, kiddo. You earned it. I hope your dad, his name is Scott, and your mom, whose name is Rebecca, that's my niece, are doing well. I hope that everybody is out there doing well. And, Drexy had a little story. He knows somebody or knows of someone who's going up on the ISS that is taking one of their challenge coins that he gave them up to the ISS with him. I think that's pretty cool. Neato. Hi, Renee Cruz. Welcome. Good to see you. So, tonight we're just waiting for it to get a little darker. As you can see now, looking at the screen, there's a few more stars poking out. Here's one that's coming through. There's another one. And let's just go to a maximum. There we go. Like a little bit of a maximum view. Okay, so now we can see more stars. I'm going to try now to see if we can solve for our position right now. We had something happen, probably related to solar activity or something, and the telescope lost its position. But we're going to see. We're going to get it back, and then we'll set up the telescope to know where it is again. So we're telling it.
It's really been cooking off lately.
It has, hasn't it?
Yep, and there
sure
is
has.
a great, big, extremely active sunspot group
Oh,
just
yes.
now coming around the edge of the sun.
That's right.
These make it even more interesting.
Yeah. Okay. Well, it hasn't stopped yet, so it might be able to solve for this field, even though it's still light out there a little bit. If it can find this field, we're going to put in those coordinates, and we're going to get ourselves set up. So we're just waiting for it to come through. I think that's enough stars. I think you can see them fine. They're not even focused yet. Well, they're sort of focused.
Other news while we wait.
Yeah.
A month from tonight, in fact. Well, a month on the 15th here in the U.S.
That's right.
It's going to be a total lunar eclipse. And it's going to be well placed for South America and North America.
And who will get to see it? I mean, on the East Coast, West Coast versus Central?
It's ideal for South America. It's a little better placed for Eastern North America. Uh, the moon will rise here while it's in its penumbral phase, and maybe still barely so from Arizona, since you're a half an hour sky time west to me.
Mm-hmm.
But it'll, the partial phase will start pretty soon after it rises. And my concern is your eastern roof may be in the way for early phases.
Actually, maybe not, because the eastern roof is that the moon actually rises more in the southeast there than the east. So we'll have an earlier view of the moon than you think.
Okay, well, we can always hope.
Yeah, and because it's bright, we could actually have the telescope impinging on the roof a little bit, and we'll still be able to see it.
Very good.
That's my guess. All right, so we're now looking at this scene, waiting for a green bar to say here that it found it. And I would actually just like to move this down just a little bit. There we go, so we can see the reading, that writing up there. Little bit of a thing that maybe some of you noticed, maybe you haven't. There's a lot more real estate available now on the screen. We're showing much more information on the screen, so we've actually set it up to do that. Hopefully that won't be a problem for people. Make sure you're in 1080p, by the way, when you're watching this on the web, on YouTube. That's kind of important if you're looking at stars. Right. Hello, Jessica S. How are you? Nice to see you. All right, let's just wait this out here. We're just waiting for the telescope to find its place in the sky. It's harder when it's still light out, and it's a little bit light out there, so it's having a tougher time. This is kind of a test for me as well. I want to make sure it can do it.
Full moon tonight, too, of course.
That's right. So that adds to the problems.
Yeah. The moon was actually officially full at opposition at about right before 1 p.m. my time, Mountain time. So let's see, 12. It's about 8 hours. A little over 8 hours ago, or a little under 8 hours ago.
Okay.
Opposition is when the moon is 180 degrees from the sun in the sky.
Yep.
Means it's opposite the sun in the sky. And that is the definition of a full moon. And the moon actually slowly moves west-east as it orbits Earth, about its own diameter in an hour. So,
yeah.
Strictly speaking, it's about 8 hours past full moon, but looking at it naked eye, you'd never know the difference.
Exactly. And while we're waiting, you'll notice that the stars of winter are indeed past the southern meridian here and heading into the record books for this year. We can still look at stuff out here for a while, but then we're going to be into the galaxy season. But if we keep going over this way, you're going to notice over in the southeast here, there's the moon. It's already up. All right, and there it is, and it's full.
Yep.
Yeah.
Something I hope to share with you and everybody, the next dark of the moon, if you look at that part of the sky right there to the left,
yeah,
where you were, there is Crater the Cup right there.
Yes.
And just to its left is Corvus the Crow.
Yeah.
Okay, and then Virgo is right above it.
Mm-hmm.
Well, you asked recently about the Antennae galaxies.
Oh, yes, I can't wait to image those.
Yeah, and if you can see the lower lip of the cup there, just below center, right there. And if you draw a line down to that bottom right-hand star in Corvus, right there, about a third of the way down that line from the lip of the cup is the location of the Antennae galaxies.
All right.
And hopefully we'll give the moon a few days to go away, and
maybe check it out fairly soon.
yeah, maybe we can look at it. It's probably that little blip right there.
I'm wondering if it's this one. NGC 3923. That's a single galaxy. It's not. I imaged them from here. Oh, maybe this is it here. 3904. Well, is it 3903 and 3904? Is it these two?
That's almost too far apart for.
I think so, but look it up.
So
get the NGC. I'm probably gonna have to redo this search here. It's still not quite dark enough, but so I'm gonna cancel it and redo it again. As it gets darker, it's gonna be much more rapid.
The Antennae galaxies are NGC 4038 and 4039.
Okay. All right. All right. So let's.
That'll certainly be something to scratch off the list once the moon gets dark.
Yes, indeed. All right. So let's do this. Let's go up. It's funny, the more you look in the night sky, the more you see things and you say, hey, I know what that is. I know where I am. And you don't even have to see the coordinates or anything. You know? Okay, this looks like a promising field. So let's do a search on this.
Jessica, do you know why they call it the pink moon? That's the full moon for this month is the pink moon. It's not that the moon's going to look pink. It's that, well, they call it pink for all these spring flowers.
Ah. Well, that's nice.
Yeah.
There we go. Okay, we got our coordinates. This should be around 7 hours. Okay, good. All right. So we will take these coordinates and put them in the right ascension over here. It's getting dark enough so that works fine. All right, 7:52:51 and minus 16. 15:28. All right, and then this goes here, and then we synchronize and make sure that it goes in. And then we'll say sync, and we should watch these numbers change. Let's see if that happens.
Izabela's here.
Hey, Izabela. Okay, it didn't sync, so that means we move this over and see if I've got an exception, and I did. Okay, so here's what I'm going to do. I'm going to disconnect the telescope from this right now, and I'm going to also disconnect the telescope from this. All right. All right, we're going to do that. Okay, so it's disconnected. And get rid of that. I'm still into that stupid 1 second delay because I don't have the Starlink hooked up to this yet. That's gonna take a little more effort, and someone has to do it out there. Okay, so now we're gonna kill this and restart it. Okay, now it's gone. Telescope doesn't know any different. It's gonna be just fine. Let's start it up again. And now we're gonna connect again. Oh, that didn't have to happen. Okay. There we go. The full moon is always wacky, isn't it?
Oh, that's the popular thought.
Yeah.
Sort of a self-fulfilling prophecy, actually.
That's true. All right, the lights will go on here when this is up. Here we are. And I think that the declination was the last number I had in here. Let's go see. Yeah, minus 16, 15, 28. And let's do the right ascension again. That's the east-west motion, our coordinate. So let's do that and put that in here. And now, okay, 0, 7, 52, 51. Now we say sync again. We should see it was synchronized. There we go. Okay, so the telescope is all synchronized again. Sometimes I have to quit and restart. I don't know why. It's just a pain in the buttocks, but it does what it does. Hey, at least I can do it from all these thousands of miles away. That's something different, right?
21st century problems.
Yeah. Hey, do you remember, Daryl, when we actually used to have to try and hunt down something we recognized to actually set up the coordinates? Hello there,
Oh, yeah.
satellite. Yeah.
Yep,
Well, not anymore.
I remember wandering around half the night one night trying to find
I remember.
something we were...
That's right. Okay. Let's make sure that the telescope is going to do what it's supposed to do here. All right. Beautiful. Oh, it's getting dark now. That's good. Okay. Let's start up our planetarium browser. And when that starts up, we can connect it again. I guess it started connected already. That's even better. Magic. Okay, then this comes over here. So you get to see the behind the scenes, like the setup of the night, you know? By the way, I think I said hello to you, Izabela. Hello there. Yeah, I did. All right, let me bring this down here. And as I mentioned, we're using more screen real estate now, so the views are going to be more expansive, just a bit. So that's good. All right. Okay, so this is our planetarium view. The telescope is connected to here, and now if we want, we can go to Sirius. Let's actually go to Sirius, the bright star, and make sure that everything is working right. So tell it to go, and you'll see the telescope move over my head here. There it goes, and it should just go straight to Sirius because that's one of its bright stars, and that is Sirius right there. And we're going to do that. There we go. This is our enhanced view. It's sort of like a live enhanced finder view, basically, that gives us the view. It's actually 4 full moons across and 3 full moons tall. So that's how big our field of view is, okay? Yeah, and now it's centering Sirius. You can see there it says auto centering, and then we're ready. All right, beautiful. So we are good. So while we're at Sirius, you notice how far the telescope's leaning over up there. Why don't we actually... let me see something here. Is this which... Apparently... Hold on, let me just bring this up now. There we are. Okay. And I got another one back here that I don't need. Don't know why. Oh, I know why. Okay. We're good. All right, so now we're here, and boy, I don't know. I mean, should we... Let's do this. Let's bring up the constellation lines, and let's bring up the identifications. Orion is heading into the southwest now, but there's still some really cool things here to check out, so let's do that.
You've got M41 there, Little Beehive Cluster just below Sirius.
That's where I'd like to go right now and check that out.
M41 star cluster.
Yep. So
I believe you said earlier tonight you thought it'd be a good night for clusters with the full moon.
That's right. So tonight is cluster fun, stars and more stars. You know, as opposed to another type of cluster that it could have been if something had gone wrong. But we're covered. We're fine.
Charlie Foxtrot night.
Yeah, well. Do you want to tell everybody? No, don't tell everybody. Okay. Renee Cruz says, I was watching the new reboot of the In Search of on History channel, hosted by Zach Quinto, new Spock, and discovered extraterrestrial alien signal corresponding, and we responded in 12 years we'll be invaded. Okay. I actually did, I did that show. They had me go to Boston, Massachusetts to film one of those episodes. So that was kind of fun. Yeah. So, interesting stuff that, I've said this before. Stephen Hawking said, as we go here, I'm going to tell the telescope to go. You watch over my head, you'll see not much change because I'm telling them to go to the Little Beehive, and it's kind of in the vicinity of Sirius. All right, but see, it's going to just move this aside just a little bit, bring Sirius back into the view because that's its waypoint star. So we just happen to be here. Hey there, Rock. Rockstar is here. But what's interesting is that we were told by Stephen Hawking to lay low. Lay low. Don't do anything. Don't let the aliens know we're here. And you know what? That's wise. That's a wise counsel. But the fact is, we've unfortunately been more than obvious to alien life for 2.5 billion years. And I mentioned this before, and it has to do with our oxygen in the atmosphere, So there we go. So with that oxygen in the atmosphere being what it is, we don't have the option of hiding because it signals that something's here that's replenishing oxygen in the atmosphere because it doesn't like to stay in the atmosphere, as I've mentioned a bunch of times. Look at that.
Mars needs women.
Mars needs women. Yeah. Okay, I'm going to go out here one level. And let me first... I'm going to go... It's refocusing right now, but as you see, it's going out of focus, which is what I want, because I'm now going to train it. Actually, I'm going to have the autofocus do its work to get us moved inward. So it's out of focus. Now we're going to go into focus. Okay. So we're going to. What's that?
Marianne is here.
Marianne Robb. You know what? Marianne Robb is actually on a field trip. Did you know that? She's on a field trip. Yeah, she's in the Kaibab right now. Up in northern Arizona, on the northern rim of the Grand Canyon. Yep. You don't think I would stream without an emergency backup, do you? So if something goes terribly wrong, she's going to have to drive down from the north rim of the Grand Canyon 20,000 hours to get home to go out to the desert to fix this. Nah, she wouldn't do that. I always make sure if no one's around that there's no rain in the forecast, which is a good bet for where we are. And especially no wind and dust. Okay, so we're going to scan in now and start our process. So here we go. It should scan inward and build us a little curve. And at the bottom of that curve is our focus.
It's been unbelievably windy here.
Yeah.
And really, I mean, one day it's warm, the next day it's cold.
Yeah.
It was down in the 20s a couple of days ago, only got up in the 30s, and 100 mile an hour winds and snow up in the mountains. And it's just been dry as a bone down here, and we're in red flag warning fire danger.
Wow.
All over the state.
Wow. That's bad. Marianne says, I would do that in a minute if she had to come back down and figure, well, you know, she has a lot invested in this too, of course, as one of the benefactors of SkyTour LiveStream. So let's go here and wait. We're on step 11 of 12. There's our curve. Look at that nice curve. See that? The bottom of that curve, that's where the focus is the optimum. So it goes from out to in and then out again so that it knows the curve, and then we're going to bring it back. So it's completed, and now we're going to say go to the best position, and it's going to go all the way across and then all the way down here. So watch that little vertical line go past all the way to the right side and then come back to the optimum spot right there. And now look at our stars, the little pinpoints. Isn't that great? And now we're done with that focusing. So what we can do now is we'll set our temperature compensation. That's that little T comp you see right there. And that tells us that our focuser is going to be compensating for the temperature change as the night wears on. And this is a wonderful pre-Easter stream. It's been a while. It's been a few days. Marianne says to you, Daryl, that's what's going on in Arizona now. Fought the wind all the way up there, she said. So that's bad. Or good, depending on whether you like wind. Okay. Let's do a stack on this. Let's do a... this is Messier 41. Let's do a stack of 10 seconds. Alright. And we'll say a live stack on that. And we're going to knock off our enhanced view here so we can actually show it the way it should be.
I bet Marianne would settle for a Ferrari.
You think so?
308. Yeah, she could be like Magnum PI.
Okay, hold on 1 second. I don't know what just happened, so I'm going to clear that. And do this again. Okay. Oh, I know why. I had done a live stack before and then killed it just as a test, so now we'll get stars. Okay. I'm also at 0 gain. That's the other thing too. I'm going to bring our gain up. That's a problem I had. I'm going to go to 300 gain tonight. And let's clear it. Oh, I think I... Alright, there we go. So now let's get our first image. There we go. All right. So there's our beautiful image of Messier 41. Let's see if we can do a little processing to pull that back a little bit. It's going to be a little bit bright because, look at all those stars. That's beautiful. Yeah. Messier 41 is a beautiful sight tonight. That's really nice.
It's a pretty open star cluster.
Yes, it is. It's pretty and it's open, and it's open to change because they all are. There we go. So you see, here's the thing, guys. When you look at this, you saw a few stars. You saw a lot of stars, but now look how many more stars you're seeing. This is how it works. You know, there are many, many stars out there that you just don't see. And if you look, some of these stars are orange. Like this guy right here is orange. Okay, there's an orange star, another orange star. Lots of orange stars. These orange stars are actually stars that are potentially red dwarf stars. M-type stars on the OBAFGKM scale. We're hottest and bluest like my lights, down to reddest and coolest. All right. And reddest and coolest are stars that are really, you know, I would say kind of like this. Okay, so now you have reddest and coolest stars, right? And that's kind of what we're seeing here. Most of the stars in the universe are these red, cool stars like you see here. And we'd be feeling the light. That's would be the light we'd be getting from them. And they're also very faint overall. Right, so they can go from blue. They can go from these blue stars, okay, down to these beautiful red. So hot blue stars can be very, very bright and blue, and then the orange and the red stars are the ones that are the most prevalent ones in the universe. The hot blue ones, there's actually relatively few of those. There's a lot of white ones, a lot of yellowish ones, but for the most part, it's where red is where it's at, you know. Yeah. So we're doing okay here. It looks like the 10-second guiding is good. I'm actually going to stop it here. We've stacked a bunch of frames already, 16. So I'm going to pause it, and I'm going to put it in here as Messier 41. And it's an OC or an open cluster. Okay, there we are. And now we'll come back and save it. And you'll get to check it out. So we hit save, and you'll see the green bar across the top. That's saving the astronomical image format that we use a lot in FITS format, FITS. And then I will also save it in something that you can just double click on and see, and it's save exactly as seen, and now you see the PNG file right there. Okay, now for those of you that may not remember, may know, everything we take pictures of is shipped out of the observatory right after it's taken, goes up to a server, and gets down on a server that's publicly available for all of you to see and go check these images out moments after they're taken. And I think that's great. You know, no one's doing that, and it's like, it's a shame because astronomy is really for everybody, you know. Okay, so now what we're going to do is we're going to clear this, and we're going to come out of this right now, and we're going to come over here and go to 1 second exposure and go back to our finder view that I like to call it. All right, and there it is. You can see some of those stars, but not all of them. And that bluish color you see, that's the moonlight in our camera view. We get rid of that, as you saw in our system. Now what I'm going to do is I am going to move us down a little bit. Okay, and you can see that right there. You can see that the telescope is here. And I'm now going to change our settings for our guiding system. I think that's important. And the guiding system it's a separate guide scope on top of the telescope that you don't get to see because it's sort of behind the scope right now. It's up on the other side of the scope. And what we're going to do is we're going to set up the guiding parameters that I know have been working. All right, and this is going to be, let's see. Let's go up here. Okay, this, I'm going to get out of that. I don't want to jump into that yet. All right. Yeah, that's not right. That's not what I want. I want it to go up. And we're going to set this rate. And we'll set it to 15. All right. And then we'll go back down and change that's the east-west rate that I just changed. Now we're going to change the up and down guiding rate, and that's going to go to 17. Yeah, there's a bit of a delay, obviously. We're waiting for it to go 22,000 miles out and then come back. That's how long it takes for us to get our signal because we're using geosynchronous satellites. But that's going to change. We're going to be using Starlink, and the difference in time will be almost nothing. So it's going to be much, much nicer. Actually, everything's there. All the hardware has arrived, so now it just has to be installed. And I'm going to be getting that done.
Your adapter?
Yes, the Etherlink adapter has arrived, so now I can pick off the network because it only comes with Wi-Fi now with Starlink. Who knew? It changed, and from the time we ordered it to the time it arrived, that's what they changed it to. Okay, all right, we're good. So now let's get out of this. All right, and now let's go to our planetarium system and let's look for some more clusters. Yeah, what's that guy?
Spring's a good time for globulars too.
I know it. I'm looking forward to that. All right, so okay, we're gonna go and check this one out too while we're here. All right. People know what I'm gonna do with this one because they know. All right, here we go. Okay, telescope's gonna move just a little bit.
Thank you, Izabela.
Ah, she put it up. So you see, it's already up there, guys. Already up there. Yay. All right. So we're going to have Osmodiski, or Osmodisk, and that's going to be our waypoint star right there. And from there, we're going to bounce on over to Messier 46. And there it is. And I'm going to do something with this one too, because we actually have the ability to show this with just a little more detail by having this go just a little bit to the west.
I see a green fuzzball.
I know, and I just went a little too far because I forgot to change my settings. I'll get it back.
Thank you, Vera. My mom thought I was cute.
All right, hold on. I'm just trying to get us back there without overshooting again. I guess I'm just going to have to... I'll do it this way. Do it again. Oh, I didn't have to do that, did I? That was silly. All right. We're going to go to Osmodisk again and then come back. I should have just let it do it. I could have let it do it, but I didn't. Here's Osmodisk. Our sky in our enhanced view here, our sky is going to be greenish blue for the night because, I mean, I can adjust that, okay, for the moon. So, I mean, there are some controls I can use. I can, when we're in this enhanced mode, I could make it look dark. So maybe what I'll do is adjust this a little bit. Let's see if I can adjust it some more. The problem is the closer you get to the moon, it goes up exponentially. But that's all right. We're fine. All right, so this is about right. And as Daryl said, and that's why I got rid of this green and bluish cast so you can actually see this guy. This is a very, very special spot in the sky. But first I'm going to show you something else. I'm going to do it right now. Let's go and set up our movement rate. When I use this manually, we're going to set this movement rate to be just a little bit slower. So now, as I move over, you're going to see another cluster come into view over here. And you're going to see two wonderful Messier objects in the same view. All right. There we go. All right.
I just lost my view off your shared screen.
You did?
Yeah.
Huh.
Did
you get it back yet? It still says I'm shared.
I mean, I still hear you. I mean, the voice is still working.
Okay.
Give me just a second here.
All right.
I probably clicked the wrong button.
Okay, so you'll see we have 3 open clusters in this view. Okay, we have Messier 46. You got it back?
Yep.
Okay, we got Messier 46. We got Messier 47. And we've got this one, which I have to go see what that is. All right, let's go over to our planetarium. Let's zoom in. All right. Okay. So what we're going to do is this, and it's going to show us our view. So this is where we are. I lowered that down. You can see Messier 46, the lower left, Messier 47 to the right, and then up there is another smaller open cluster called NGC. That stands for New General Catalog, NGC 2423. Where is it? Well, here's where it is. We come here, and there it is. That's 2423, that's 47, and that's 46. Now, this is a nice view because you actually see 3 beautiful objects all in one view. So what I'm going to do first is let that satellite go through, and then I'm going to move us up just a bit to get them all in view. And then I'll let it settle out. I'll let the guide star catch it, and then I'm going to move us just a little bit to the west to move this over just a tad. Okay. There we go. Now we'll let a guide star catch it, and then we're going to do a 20-second shot of all 3 of these. And here's another. Oh, you know what one went through this way, one's going through that way. Those are Starlink satellites. I'm almost certain of it. Almost certain of it. So you see, we can do lots of things in the full moon, guys. No problem. All right. I think I want to just move over just a little bit more to the west. Here we go. That's good. Now that's acceptable. Okay.
We got 46 and 47 in the same field.
Yeah, this is 46, 47, and then this one's at NGC, what did I say, 2823 or 2923?
Oh, okay.
I'll show you.
I'm sorry.
No, that's okay. At 2423. Yeah. Okay, so there's our view. Actually, right about here. That's our view right there. All right. All right. So now we have a guide star, and I mean, I could select this to show you the guide star, and it'll show you that we have a guide star. But what I'd like to do is go ahead and get an image going here. So we're gonna bring this up, and we're gonna go and do a 20-second shot. 20 seconds. All right, get rid of our hyper view here and go into a live stack. Clear the live stack from the previous one or from whatever's in there now as garbage, and then we'll see this come in right here in a moment. And what do we got? Boom, let's go. All right, so now we have it. Now that's the raw frame. All right, and what I'm going to do is do a little bit of, I'll do color process on it, and then a brightness contrast pass right here. Okay, let me do that again. Okay, so there is this guy.
It's that pink moon I was telling you about, Izabela.
Yeah, I don't think so.
The thing I made it all up about.
You didn't make it up. So here we go. Once again, what you thought might have been just 3 little isolated clusters turned out to be a whole family of additional stars, right? Like here, look at that guy. Right, that's another cluster. All right, this one we know about. All right, this one has this neat little planetary nebula in it. All right, it's Messier 46, 47, and 2423, NGC 2423. So it's really something. Neat. I like it. So we're just going to stack these, let them build up a little bit. We've got 5 stacks so far. And then we're going to, let's see if I can, when we're looking at clusters, doing masking, unsharp masking to sharpen things just kind of makes them look really harsh. So let's try it. I'll show you what I mean. See, the stars look harsher now. So when we do clusters, we leave it soft. And that's really cool. Renee says, 1978 San Francisco daytime UFO. I was 12 years old, and also a shooting star later that night. Mind-boggling. I was flabbergasted. Wow. I know you meant shooting star. Cool. Hello there, Tim F.
Okay, Izabela, here's a link just for you about tonight's pink moon. Make a monkey out of me, will you? The full moon in April is named the pink moon after the pink flowers that bloom in spring. Other names are Breaking Ice Moon, Budding Moon, Awakening Moon, Egg Moon, and Peshal Moon.
Egg moon.
You got me. My sister said, in reference to pink flowers, suppose that, what'd she say it was? Phlox, I think it's called, Phlox.
Yeah.
But just
Phlox,
generally,
yeah. It's phlox.
yeah. They say just in general is known as the pink moon after blooming wildflowers.
Wow.
So there.
Okay.
Now she's rolling her eyes.
I see that. JSCO 77. Mark, do you know anything about Kincade's Cave in the Grand Canyon? As a matter of fact, I know about Kincade's Cave in the Grand Canyon, and I was going to, and may still, join an expedition to search for Kincade's Cave in the Grand Canyon. I actually think I saw it because we were going to do a drone footage, and it's possible we'll get permission to use the drones there, even though it's a national park, because it'll be on native land, indigenous land, and they're just as interested as well. So yes, I know about Kincade's Cave, and as I said, I had some original drone footage that got sent to me, and I think I found it on the drone footage. Yeah, it is fascinating. JSCO says it's fascinating. Boy, look at this, huh? This is really looking smart. Looks good. Again, note the red stars in there. Okay. Alright, so this is 16 stacked here. That's enough. Then we're going to go back to M46. So we're going to pause this. And what I'm going to do is change the name here. Actually, I'll change it out here. M47. And I'll leave the other one. I won't add that name. But that's what we're going to do. And now we're going to save this. So it's going to save as a FITS file. Excuse me. And that FITS file, again, you can get free viewers online to look at these files if you so choose. But they're not processed. They're raw files. So if you want to see what raw imagery looks like, those are the ones you look at. When you look at this one, we save exactly as you see it. That's the ping file. That one will look just like you see here. Okay. Okay. Now that we've done that, let's go and let's get this down here. And we're going to go now make this just Messier 46. Again, just that one. No, don't change anything, because we're doing a new one. All right, and then we're going to go from 1 second again, and now we're going to get rid of the stack. I'm going to go back here to our histogram where you can see the different colors for the red, blue, and green channels. All right, and let's go to our hybrid mode that I like to call it, and boom. All right, and this is a 1 second exposure, so every second you see it change. And that modeling you see in the background, that's the noise. And when you take a stack, that noise changes every exposure. So what happens is it averages out over a bunch of stacked images. So as you sandwich more images, the white parts, the white starlight is data. If there's dark nebula, that's data, and that'll rise to the top. And all that noise gets left in the background. Hey, DK, what's going on? See, so that leaves us with some good star images. Okay, now we're going to bring this back over. We're going to move that guy right there into the middle and bring him up because we're going to focus on him and magnify him. We don't need a long exposure for this because long exposures actually hurt it because it's sensitive to long exposures. Poor thing. This is also my first stream since I got back from Arkansas the other day. I was down at a conference speaking, and it was the Ozark Mountain UFO Conference. And that was kind of fun. I have a television appearance coming up too, at the end of this month, and that's going to be where I'm going to be actually doing just my astronomy. And I'm not going to be talking about UFOs. It's just going to be the astronomy part. And I can't say anything about it. I don't think until it's over. But that's what happens. I mean, I could tell you individually, but I can't put it on a stream. Okay, here we go. This is great. Okay, now
You can't tell us to, tune in.
I can tell you when I know that I'm able to, when they say I can. I don't ever jump the gun on those things because, these are very important schedules, and I don't want them to, say, hey, you gave it away. I don't ever want to be that guy. But I'll let you know.
All right.
Okay. So here's a star cluster. This is Messier 46, and as we've shown before, it has a planetary nebula in it. Now you might think, oh, that's cool, a dead star in that cluster. But if you think about it, that makes no sense. Because this cluster is a fairly young set of stars. These stars have not gone through their lives yet, their existence. They haven't burned through their hydrogen and made it into helium in the cores and used it up. They haven't. They're young. They've got lots and lots of hydrogen to go. So why do we have one star there that has died? Is it a fluke? Is it like a strange occurrence that might happen? No, because when we see a young cluster, all the stars are about the same age. But this star can't be a much, much older star that's already used up its hydrogen and gone into the stage where it's inflated because it's fusing helium into carbon, for instance, and then bloating in size and then shrinking down over time to this little tiny white dot you see there, which is a white dwarf. That's a star that has gone through all of its hydrogen, which means that it's a very old star. So in this case, this particular cluster is something that's actually much further away than this is. This is a line of sight superposition issue. That planetary nebula is up here in the foreground, and that cluster's way back here, 2,000 light years further than this planetary nebula. Okay, so remember, space is 3D, so you turn it sideways and you're going to see all this separation between these two things. We don't see that here. Isn't that crazy? So that's how that works. Okay, I think we can do I'm going to say 12 seconds on this, Daryl, and see if that allows us to get enough data. I think it does, last I checked. So there's 12 seconds. Okay, and we're going to stack that. And we're going to remove this last stack. And let's see what we got. Okay, that might work. That's interesting. You actually see the brightest part. Alright. So what we're going to do now is this. I'm going to do a little process. Okay. We're going to bring that black level back here. All right. All right, there we go. And I'm going to just move that just a little bit more to the right. So you see these dashed lines here? Those dashed lines mean something. These dashed lines, this is the dark level, the blackness of space. If I move that over here, then you'll see that space gets much, much darker. Okay, if I move it to the left, it's going to get much lighter. Okay, and obviously that's too light. So we want to go the happy medium. But then again, what are these curves? Well, these curves are the red, green, and blue data that's coming in from the camera that makes the starlight. Okay, so what happens is where we have this black level intersect the curve tells us how black space is going to be. If we're to the left of the curve, then much of the noise will get included. If we're right at the very top of the curve, then pretty much we're going to get a black space with a little bit of noise. And then this to the right, this is the mid-tone level, the middle level. And so if we move this down a little bit, you're going to see that things start to kind of get lost in the view. But for looking at our nebula, by moving this down, we actually can see the nebula better. See, watch this. All right. So now we move this down, and this nebula, this planetary nebula now is more pronounced. And we're going to enhance it a little bit too. Because we're looking at a nebula, we're going to turn on our unsharp mask, which is designed to show details in nebulae. And that's what we're going to do. Okay. So let's go over here, go to enhancement, and turn on unsharp mask. There it goes. And you'll see the change. Ready? Okay, look at that. That nebula just got a lot sharper. How sharp? Let's go see. We've stacked 13 of these. That's quite a few. You can see that star in the middle. That's the white dwarf. That's the white dwarf in here. Okay. And I'm seeing quite a bit of detail here tonight, Daryl.
Oh, yeah. Me too.
Okay, you see it's got a red fringe. Okay, that could be hydrogen alpha or possibly neon. It's got this greenish hue to it. And we also have what look like streaks coming out. I have to confirm that those are really there, but that's a really pretty shot of it. And those that greenish blue color, that's atomic oxygen atoms that are being ionized, but not just with and an ionization means you knock an electron off the atom because the electron absorbs a lot of ultraviolet energy, and it's not just one electron but two electrons that are leaving the atom and ionizing as we see them here. And then they rejoin the atom, and when they do, they give off this blue light. Why do they rejoin? Because when they leave the atom, they lose energy, right? After absorbing all that energy, they lose it off outside the atom, and then they drop back in. And when they drop back in, well, that's when they actually give off that light. And because of the nature of how far they fall into the atom, different levels, different amounts, the light is a particular color. Hydrogen, when an electron does that in the hydrogen nucleus and jumps back in, that characteristic light is red by and large. There's other colors and other things that are happening, but by and large, the red one is predominant. Same with oxygen. The greenish blue one is predominant. This is really pretty.
It is.
Wow.
The details we see are real. We have verified these before.
Yeah.
The green stripe up at about 1 o'clock, and the red in the outer shells over at about 9 till 12 or so, and there's one at about 2 o'clock, and a bunch down around 6 o'clock.
We got that one there.
And those light-colored knots down toward 6 o'clock.
Yep. I think that's a star.
I think that one is too.
Yeah. This is beautiful, though.
Yeah.
Yeah.
It always amazes me how much really shows up with this when you just do your first real short exposure, you know, like your 1 second exposure when you're zooming in on it.
Yeah.
You know,
well, one of the things one of the things I'm noticing is that the stars are actually just a little bit out of focus, actually. So they're not quite sharply focused. I'm getting I can see this little fuzzy artifact around the stars. So when I go back out there, I'm going to check that collimation. But then again, I'm also going to run the focus routine here again. But that's okay. With 27 stacked, I think that's pretty good. And we'll pause it and we'll save this. Alright, and I've got M46 Open Cluster Planetary Nebula up there. So there we go. Let's go back in here. And we're going to save it. And then save the image exactly as we see it. Okay, and now actually I'm going to get rid of the stack and go back to 1 second here. Alright, and go to our hybrid view. Alright, and let's go out and our, oh wait, turn off temperature compensation. Let's go out on the focus a bit.
You turned off temperature compensation?
I did just now, yes.
Oh,
I can't do the focus if it's on.
I see.
Hey, that's great, DK. Thank you. Alright, so now we're going to do this focus process again. Multi-star, full width, half maximum. And for those who want to know what that is, maybe what I'll do is I'll do a little bit of a talk, tell you how that all works. Not now, but you know, at some other point. All right, let's get out of this so you can see what it's doing a little more. There we go. All right, so it's building our graph. It's got it's only on step 4, so it's coming down and then it's going to go up the other side. Once it gets to the bottom, it's going to build a curve and then shorten it and fit it to the screen so you can see that it's really a curve.
I've been
Vera
watching
says,
the weather out there.
Yeah? Who is?
And, well, you've had some big temperature swings lately.
I know it.
Actually got quite cold there a day or two ago.
Wow. Vera says, Mark, you can sell patches with the STLS logo. I'd buy one. That's very cool. Yeah, we actually, one of the things that I have here, which I'm going to update. Let me show you here. This is something I got, which I think you guys might like, maybe not, I don't know. But it's actually SkyTour LiveStream playing cards with all the images on the cards. It's pretty cool. And this was a test deck to see what I'm gonna see if I'm gonna like it, and they actually come out pretty good. Okay, here's our focus. There's our beautiful curve. Now we're gonna get back to an optimum focus.
You should do a logo patch, sort of like a NASA mission patch.
Oh, that's interesting. Kind of like the STLS, which you don't see because the wrong screen is you're seeing the wrong screen right now. But let me here, look. Let me move this over for you. Like that logo over there in the lower right corner.
I still don't see it. Oh wait.
What? See his STLS? You see it?
Oh yes.
Yeah.
I see it now. I had to move something.
Oh, okay, sorry. Yeah, that sounds like a cool idea. All right. So now, let's come in here, and I'm going to leave the temperature compensation off right now, and I'll tell you why. Because with the massive swings of temperature, as you're talking about, I'm not sure that this is doing us any a service here. Let's do another set of 12-second shots here. Refocused, and let's try it. Go live stack. Alright. And let's clear this. Just in time.
A mug would be cool. Vera suggested that.
Yeah, I was thinking mugs are cool too, yeah.
The one company I've seen that does that some people on YouTube use is Cafe Press, and God, they're expensive.
Yeah, Vistaprint's another one.
Yeah, I have used Vistaprint in the past, and they're actually, I thought their prices were decent.
Yeah.
I had them print some stickers up for me once.
Yeah.
Some years ago.
Okay, this
Cafe
focus.
Press, they like to sell all the, mugs and clothing items, you name it, and they are not cheap.
That's true. Well, this focus is better actually, so now you can see even more detail making its way out. This is 5 stacks so far. That's not bad at all. Look at how detailed that is in there. That is really pretty. Now keep in mind, guys, that we're at 150% on our sensor right now, meaning we're at a zoom level of 150%. This, if we fit it to the screen, this is how big that little thing is right there. Look at that little thing. See that? So we zoom in, and let's go to 100%, like, because that's really what it should be. All right, so let's go to 100%. There you go. Wow, look at that. That really looks nice. I'm really impressed with that. And here I go. I'm moving in even more now. This is 117%. Let's go crazy.
Object that just really could stand some focal length.
Yeah. Well, the next system that we put out there will be a side-by-side where it's going to be a higher focal length system.
Yeah. Izabela, one of my sisters, gave me a mug like that. It changes, with the temperature, and I'm afraid to use it. I don't trust the inks in it.
I actually have I have a mug that is Captain Kirk and Spock on the transporter pad, and when you pour in hot tea, they go, and away they go. That's clever. Wow.
The mug I'm using right now,
Yes.
I have my tea in, is oh God, I bought this thing over 20 years ago. It's Colorado Springs Astronomical Society.
Wow.
And one of the club members designed a nice logo for it, and it's printed on both sides. It looks really nice. I've managed not to break it yet, so
that's
knock on
cool.
wood.
Yeah, I have one from the KGB, the Russian KGB. I have one. Oh, that one was given to me by a guy in the defense arena. And then I had another one, a couple that are pretty interesting. Alright, that's neat. This is pretty. Look, we're up to 18 stacked already. We're going to go to 20 and then stop at 20. But this is nice. This is pretty nice. Alright. There we are. We're at 20. So we're going to pause this now. Save it. This is a 12-second exposure. So we're actually seeing some nice detail in this. And we have the name right up there, Messier 46 Open Cluster Planetary Nebula. And then we'll save it exactly as seen so you can see that detail very nicely. Alright, and then let's get rid of the stack. Actually, let's clear it first so when we start up, this is pretty. Alright, and then 1 second exposure, and then let's hyper that view so we can see it in detail. There we go. And let's go from 122%, as you can see up there. Let's go down to auto of basically fill the screen frame. There we go. Okay, now let's go and move to a different object. Alright, what shall we do?
Any good globulars close by?
Let's go find one. There's gotta be something nearby. I have Messier 48 up there, but it's not a globular, it's just OC. Open cluster. How about over here? Here's the moon. This planetarium program dutifully removes from your view objects if the moon's too bright, which I think is kind of interesting. All right, let's go look up north.
Try Messier 3.
Yeah, Messier 3 is nearby. I know that. I saw that. Might be near the moon, though.
Moon's in Virgo, I think, and M3's up in, where is M3? Boetes? I forget. Coma? Somewhere.
Yeah. Well, Messier 53 is near it, too. Let's see where we're sitting. Let's,
Yeah, that's pretty much what I thought.
Okay, so Messier 3, Messier 3 and Messier 53 should be within our range. So let's go there, shall we? Might go to Arcturus. Might try to go to Arcturus. But let's go. Messier 53. I'm sorry, Messier 3. And away we go. Okay, watch the telescope move. There it goes. Zingo! That's quite a move, guys. See that? Look at it go. It might get a little low here. Yeah, it's getting kind of low. Let's see what it's trying to bring into view. Is it going to be... Let's see what star. Mufrid. Trying to bring in Mufrid. Where's Mufrid? That's got to be pretty low. Oh, it's down here, see? Okay. Well, it's going to go north more to get to Messier 3. And then that clears us of the building, so that's nice. Yeah, we should see Messier 3 right there, and there it is. Nice. Ta-da-da-da. Ta-da-da-da-da-da-da-da. Okay, so we're going to just do this now. We're going to center it up. Alright. Let's center you up. Right. Okay, and let's move move us over a little bit. Okay. That looks good. And now, let's see, maybe a 14-second exposure. Okay, that's what we're going to do. 14 seconds. Drop that out of that. No hyper, and just go in now to our our view. I cleared that. All right, and here we go. Boom. Hey, look at that. That's a beautiful globular cluster. You can almost hear the stars roaring deep in that cluster. There we go.
The moon is in the feet of Virgo.
Yeah.
Whoever said that a minute ago.
It's actually pretty close, relatively speaking. It's actually not that far away.
Yeah, it was over in the upper part of Virgo last night, I believe. It's in the lower part of Virgo tonight, near Virgo's feet. It'll be in Libra probably tomorrow night.
Vera, you're funny. Like James Bond. My name is Bond. James Bond. That's funny. Those diagonal streaks I'm going to take care of. That's actually an artifact in the camera on the filter. And those will be removed in my visit out there. There's all kinds of little things, you know. What can I say? Okay, now one of the things we can do is we can actually drop this mid-level down, and that'll help to reduce the saturation in the middle of the cluster. You'll see the more stars available when we do this. See that? At 14 seconds, we've actually got... It's too long. For this object, it's too long. Really pretty, though. By the way, thank you for joining us tonight, folks. I'm glad you guys came along. Hey there, Fractal Frog. How are you? Frog. Fractal Frog. Ah, see? I'm Fractal Frog, see? Nobody can stop me because I'm Fractal Frog. Who knows the name of that cartoon character? Go ahead, put it in the chat. And what cartoon he was in.
Do that again.
What? The frog?
Whatever.
The frog voice?
Yeah.
Alright, it's like, I'm the frog, see? Nobody can stop me because I'm the frog.
Well,
name the cartoon. The cartoon. Because the character's called the frog, but what's the cartoon he's in?
Is it Looney Tunes? I want to say that's supposed to be Edward G. Robinson. The gangster guy.
No, OG Skywatch. Hey, how you doing? No, it's a gangster. It's a gangster cartoon character. And it might be Edward G. Robinson as a takeoff, but what cartoon does he appear in? He's a main character, and he's always the bad guy.
Don't know.
See?
Well, that's Edward G. Robinson. I know that.
Daisy and Zoe Amethyst got it right. Well done.
Courageous Cat.
Yes. Yeah. In fact, that song was like dun 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 bum 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 bum. That's what it was. And it was Courageous Cat and Minute Mouse.
I don't
Hey,
remember
Minute
that at
Mouse.
all.
Oh, courageous cat. I can't do it anymore because my right vocal cord is gone, so I can't do those highs anymore, which is great because those courageous cat and Minute Mouse are one of my imitations I used to do. Not anymore.
I don't think I remember Courageous Cat.
Oh, well, you know, it wasn't that good.
But I do remember Edward G. Robinson in a cartoon.
Yeah. Oh, look at that.
And a frog. That's very nice.
That's beautiful. See, this is what happens when the telescope is focused and collimated. You can see these little tiny stars. Look at how small those are. Look at the tiniest of stars. You can see them. It's really pretty. And we're actually looking at it through atmosphere, you know. Oh, yeah, Mighty Mouse. Mighty Mouse, that's right.
Here I come
To save the day. Dun, 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 dun. Here we come to save the day. I can't remember the song because I'm poisoned by Andy Kaufman when he did it. As a joke. All right. What a beautiful image this is. All right, this is 25 of those, so we're gonna say that's good for now. And I'm gonna change the name on this. This is Messier 3. Messier 3, M3, and it's a GC.
Marc, will you excuse me for a moment, please?
I will excuse you for 2 moments.
Be right back.
All right. So we're gonna save it now. And then save it exactly as seen. Like this. I lost track of the other dog I'm watching. He's here somewhere. I have a cattle dog, Dingo is her name. Australian cattle dog. And I'm watching a second cattle dog for the weekend. And it's just hilarious to watch these two dogs together. Today, they went outside and they saw a rabbit. And just like bullets, the two of them went right straight for this rabbit. The poor little thing got scared, ran under the shed, safe and sound. But the thing about these dogs, they don't chase things to kill them. They chase things to herd them. H-E-R-D, to herd them. Dingo has often, caught rabbits, so to speak. And what she does is she stops in front of them and stomps her feet around, getting them to move. She's never, ever attacked a rabbit. But she chases them to corner them, pen them in, make sure they don't escape, and she's really good at it. And the poor rabbit just sits there going, well, you gonna eat me or what? But no, Dingo doesn't kill the rabbit. She just has fun with them. Pretty interesting how that works. Okay. Oh, nice. I think I did this already, but I'm going to do it again. Okay, so that's Messier 3. Beautiful. Beautiful, beautiful. Okay, and then we're going to clear this and go to the other Messier object that we saw as well, the other globular cluster. Alright, so let's take this and go to 1 second again. Alright, and go hybrid mode. It does look like a cluster of diamonds. That's what Vera Lucia Campos said. It looks like a cluster of diamonds. It's beautiful. These clusters can have, and do have, tens of thousands of stars. And sometimes those stars are among the oldest, and in fact, most times they're among the oldest in the universe. These stars have very little elements in them other than hydrogen and helium. There goes a satellite. Very little, and the reason is because of the fact that they're so young in the universe. The universe didn't have a whole lot of non-hydrogen and helium elements by that point. There weren't a lot of supernovae that had gone off to that made new elements, and not many large stars that actually made new elements by that point when these stars were made. So, and it's really a mystery how these clusters form. That's really something, and I'm very much intrigued by how they formed, but we don't know. Okay, I'm gonna now take us to Messier 53, which is right here, I believe. Yeah, Messier 53. All right, so here's what we're gonna do. I'm just going to tell us to go there, and it's probably gonna go down to this star again to find it. But let's find out, shall we? There we go. We're getting a little glare on the roof of the observatory from the full moon. So that's why it looks like it does. It's going to a different star, though. That's good. All right. All right. Every globular cluster is a little bit different. Every one of them. Really cool. Alright, let's do this now. Let's drop down a little bit. Oh, 1 second. Okay, and then we're going to head west a little bit. Yeah, Izabela, that's a good question. You know, globular clusters are the mystery that we don't really have a good handle on. And that's, there's ideas as to how they formed, but nothing concrete, actually. So, there's room out there, you see, for research. Okay. So that's centered enough. And now what I can do is okay, now what I can do M53.
Okay.
All right. And now let's go here. Let's center up on this guy. All right. And now I'm going to tell the telescope now to sync up with that object. Let's see if it will. We should see this go here. Okay.
Sorry, I was away. Did you answer Izabela's question?
Oh, she's asking how they formed?
Globular clusters, yes.
Yeah, I just saw it. Yeah, no, the we don't really know how they formed. That's the problem. There had to be some type of clumping going on in the early universe to allow lots and lots of stars to form like that. But again, they're among the oldest stars in the universe.
Yep.
And they're all gravitationally interacting with each other. So they're kept in this cluster, but they're called halo objects. They're always outside, circulating around galaxies, or in big galaxies, they're going through the disk, coming out the other side, and just continuing to go around. So it's possible that they're leaving stars behind, gathering stars as they go. They have a really interesting past. You know,
some do think they were, as she called them, proto-galaxies.
Yeah.
They were the forebears of some of the first galaxies.
That's possible. I don't subscribe to that theory myself because they have such an incredibly tiny mass compared to galaxies. So I'm not in that camp myself.
You might think of them like, the seeds that became galaxies.
Yeah, I understand. More research is needed. There's more research needed for that. Let's bring this out now a little bit.
They are among the oldest stars, though. They're. I never got this. I guess they call them population 2 stars.
Yes.
But they're like the earliest generations of stars. They're very metal poor stars.
Yeah, that's that's why. That's why they're stated as population 2. Because they don't, and I mentioned that earlier. I think you might have been gone when I was talking about it, but they're actually stars that don't have a lot of elements other than hydrogen and helium.
Right.
And we call everything else other than hydrogen and helium a metal. Go figure. Us astronomers, we like to confuse you.
Yeah. My thought's just always been, if they're metal poor, if they're the oldest stars, you'd think they'd call them population 1 stars, not population 2.
Yeah.
But there you go. And yes, Izabela, they are older than the galaxies.
I'm not sure if that's a foregone conclusion. They're at least as old as the galaxies.
Yeah.
And the galaxies,
talking, at least the oldest globulars, you're talking like 12 billion years old or something, aren't they?
Yeah.
Something
But the
like
galaxies are also similarly up there in their age as well. Oh, this is pretty.
This one's pretty highly condensed.
Yeah.
You see the globulars vary too. Some are pretty loose, some are tight.
Yeah.
Some are very condensed in the center and some aren't. Some are much bigger than others.
Yeah. I want to try and find.
I've talked about Omega Centauri before.
It's coming up. It's going to be coming up soon.
Yep. Some globulars, like M13 and Hercules, they say that's maybe the best globular in the northern sky. I forget. It's like, 150,000 stars or something like that.
Yeah.
When you look at Omega Centauri, it's like 4 million stars in a cluster, and it's far down in the southern sky, but it's about the size of the moon in the sky.
It is visible from where we are in Arizona. It's not visible at the moment.
Yeah.
But
I was checking that the other day for you too. That right now I want to say it's highest after midnight in Arizona, but
yeah.
And Centaurus A galaxy's right above it.
It is. We'll see that.
That's one to see.
Yeah. We have the Crab Globular Cluster near Antares, but that's not. But that's not where we want to go. We want to actually be. I think we want to be
looking
over.
for Centaurus.
Yeah, it's down
Right,
here.
Virgo. It's straight down under Virgo.
Okay.
Go back to the west.
Well, to the west here. Let's see.
The other west. East. Well,
Wait.
yeah, west.
All right.
There's Sagittarius.
Yes. Let me get rid of my.
Scorpius and.
Get rid of my lines.
You can find Virgo. Centaurus is right down on the southern horizon, south of Virgo.
All right, so we're actually. All right, let me just back out. So I have the ground turned off here, so that's why we're gonna be staring at the ground. Okay, so. Okay, there's Vela. So let's go back to. It won't be south, it'll be like in the east. There's Centaurus A. There we go.
Yeah.
Well, Centaurus A is up now, but it's actually gonna be kind of low.
Very low.
Yeah, like 3 degrees.
Yeah.
And if we remove the ground here again, you'll see Omega Centauri is going to be right about here. Right there, okay.
Yeah.
Yeah, and that's actually just the zenith lines. If we look at the equatorial lines, they'll be in a tight slant right here. So you see that it's going to come up higher, all right, and in the south, all right, we see Omega Centauri just above this line. The highest it's going to get is it's going to be right about here, which is going to be we're looking at about 8 degrees or so, maybe 9 degrees, but we'll be able to see both of them with the telescope. We're going to have a little bit of an obstruction, but we'll see them, you know. That's why I want to get the lifting columns. The lifting columns on a night like this, if we're looking at this, would be perfect, because then we can just raise it up. But, of course, you got to remember that anytime that you look at objects that are close to the horizon, you're seeing them through a lot more atmosphere, and they just don't look that good, unfortunately.
I caught Centaurus A from here in Colorado once. I probably told this before.
I don't remember that.
It was 1986. I think it was April. I was up on a hill up in the mountains looking south, and Halley's Comet had was at about its southernmost point at that time. It was barely above the southern horizon, and I was hunting for Halley's Comet, and I caught Centaurus A in the eyepiece completely by accident. I wasn't even expecting it.
Wow.
But it was obvious what it was, and it looked just like the pictures too, even so close to the southern horizon. It was really tremendous.
That's cool.
Only time I ever saw it.
Dean Bustador, he says, I thought your cursor was mine. I was freaking out for a minute. That's funny. Very, very funny. All right, let's see. We've been stacking this for a while, haven't we? I bet you we got we got 48. Yeah, that's kind of a lot. It's a little too many. Not too many, but let's just darken it up a bit. Do some processing. All right. Move it on over. Move it on over. And let's go ahead and soften this a bit. There we go. That's nice. As I said, these diagonal lines I'm going to get rid of when they get out there. It's a manufacturing defect that I can get rid of. Alright. I will back out a little.
Manufacturing?
Yeah, I think it's actually on the filter. I clean the filter very carefully, so I think there's a defect. I may have to swap the filters out. Which I have another one here to do that, just in case. Okay, so Messier 3, this is M53. Okay, let's get away from the moon so I can see stuff. We can see the real beehive, which is really pretty right now.
Yep, just west of Leo.
Yeah. Okay. Yeah, we're...
Can you show your horizon view straight down from where you are? You see there's Orion setting. Rigel is down already.
Yep.
Sirius is not far behind it.
Yep.
And then you'll see up above Procyon, Castor, Procyon, Pollux, Castor, and Capella. Those are the easternmost stars of the winter circle. And once Sirius and Rigel are down, all that's left is Procyon, Pollux, Castor, and Capella, and they're called the Arch of Spring.
There we go.
They're the sort of the northeasternmost stars in the winter circle. When everything else is gone, they make the Arch of Spring. What next?
What?
What are we looking for next?
I've just got to do this first, and then I'm going to... Okay. And let's pause this and save it. I think 68 frames is a good stack. More than enough.
You need Wikipedia for that, Vera. That's committed to memory.
Okay. Good. All right. So we'll clear this now. Messier 53 is now up, heading to the server. And let's do this now.
Alright, I was going to bake a cake tonight.
You were?
Yeah. Easter.
Oh.
I was going to make a pineapple upside down cake.
Well, just make a regular pineapple cake and drop it. Then you're all set. Alright, let's go check out the beehive. If I recall, last time we tried this, the beehive, the coordinates of the star that was our waypoint star were wrong on the database. But we'll find out. It's actually going to be pretty low to the horizon. Telescopes can go all the way to the other side of the sky here. There it goes, getting quite the workout. See it go? High precision slewing, we're getting a star in. Let's see which star it picks. Epsilon Hyades. Epsilon Hy... What's that? Hydra. Epsilon Hydra. Well, that's a different star that it used for centering. It depends on the time of night that we do this, so maybe it'll actually bring us to the right thing. If it doesn't, it means the coordinates of Praesepe are off. Okay, we're at 40%. Let's come out here and go to where we should be. It's auto size. Okay. All right, looks like the coordinates in the database of Praesepe are off. All right, so it's nearby. It's just a bit off. So let's go and... All right, so we're gonna go and move to the west a little bit. As we move to the west, you'll start to see Praesepe come into view. You can't miss it. And we're going to go north a little bit too. Here it comes. Alright, so we were able to determine that Praesepe it has the wrong coordinates in the database. You're gonna make a pineapple upside down cake with green chilies?
No. Bonnie wanted my green chili cornbread recipe.
Oh. Okay, here we go. Alright, well there's Praesepe. Now we'll do 12 seconds on Praesepe. But after we get a guide star. Actually, let's try something here.
Messier 44.
Yep, M44. So if I hit enter on Starlock, the status right here. You see it says searching. Now it has a guide star. When it stops saying searching, now it has a guide star and it's correct, so now we can take our exposure. So if I just leave that up, we'll always be able to see when it's ready. Okay, so now let's just do we'll do 15 seconds on this one because it's fairly distant from the moon right now. And let's come out of this. Let's live stack. We should be clear in the live stack. And I'm gonna mention that this is Messier 44 and it's an OC, an open cluster. Alright, let's come in here and let's come in here and let it do its own version of where it should place the curves. Alright. Let's move this over. Actually, let's do a color correction. That should bring those curves back together. There we go. Nice. Okay, so this is our perceptual cluster. Praesepe. Looks really pretty.
Yeah. M44, Praesepe was known to the ancients, the Greeks. That's where the word Praesepe comes from. Means manger. You can see it naked eye from a dark sky location. It's between it's in Cancer the Crab. It's between Leo and Gemini, and it's a naked eye object from a dark sky. It's really pretty. It's actually bigger than the Pleiades in the sky.
Hmm. You're seeing the active guiding going on here, by the way. Really pretty.
Always begs the question. I've looked it up before and I forget what. I mean, it means manger. What the heck is a manger?
A manger was where animals are kept. Pen, basically. An animal pen.
Yeah.
Ippy, an animal pen. Nice. Let's see if we can pull out a few more stars. I'll bet we can.
A long open box or trough for horses or cattle to eat from. A manger or trough is a rack for fodder or a structure or a feeder used to hold food for animals. Comes from the old French Manger, meaning to eat, from Latin mandere, meaning to chew. Mangers are mostly used in livestock grazing and generally found at stables and farmhouses.
You can't hear the music, but it's got there's a nice little blues thing going now.
Cool.
This is the kind of stuff I like to play on guitar. This stuff. Just like hear the music and just riff along. It just comes out. Oh, this is pretty.
Sort of apropos for Easter, I assume. Better for Christmas, I guess. One of the Christmas carols, Jesus, they laid him in a manger. Used that for his baby bed.
Yeah.
Nowadays, we call it a beehive.
That's right. So you guys enjoying our cluster night tonight? Okay, we're gonna stop at 20 here. I've got M54 open cluster. I'm gonna save it. And then we'll save it exactly as seen. Okay. There we are. So now we can clear this. And get rid of it. And go back to 1 second. Alright. And get our hybrid view. And say goodnight to the beehive.
Now I have that Christmas carol stuck in my head.
I think I knew that was coming. I knew that was coming.
I can't think of the name of it, but the tune is playing in my head now. All I can hear it.
That's Away in the Manger.
Yeah. Thank you.
Now you got a tune and a title stuck in your head.
Was that the name of the song, Away in the Manger?
Yes. Away in the Manger. I think. Away in the Manger. I don't know. I don't know. No crib for a bed. Bonnie knows it.
Thank you, Bonnie.
And now you have the song stuck in your head and the first few lyrics. Thank you, Bonnie.
Well, it's Easter. I mean, that's Christmas, strictly speaking, but...
Yeah. I'm going to try something here. I just want to see where it is relative to me now.
What's that?
Antennae.
Oh. Yep, right there.
So we could actually image that right now.
Go for it.
Might be tough, but we can. Yeah, actually, we'll try it. This may not work, but let's give it a shot.
I remember it's like about 5 arc minutes across, so it's not very big.
Yeah. You watch the telescope, it's going to go raking down toward the horizon here. Yeah. But it's probably going to look for like Minkar or one of these other stars down here. Let's find out. Is it Minkar? Yeah, it's going to Minkar. And then it's going to go north, so we might clear the roof and thus any glare from moonlight on the roof.
This is the same general area of sky that Halley's Comet sort of disappeared into late in its apparition back in '86.
All right.
It was way down towards Centaurus at its lowest, and then it started rising again. And
okay.
If you've ever seen like orbital plots of comets and such,
yeah,
it actually started looping up in the sky, and each one of those loops was actually one year, one revolution of the Earth around the sun.
Okay.
But it sort of hooked up again and went up toward Crater the Cup and disappeared into space.
All right. There it is. This is also called the Mosquito Larva Galaxy. Who comes up with these names? Okay, we got our guide star. All right. Well, let's try this. Let's see if a 25-second shot. It's gonna be blown out, unfortunately, because it's right near the moon. But you know what? It's a good test. All right. So let's do our stack here. We're gonna clear this. I'm not gonna label it yet because we don't know how well it may come out.
Okay.
Oh, I just say it's searching. Okay, so that first image might not be perfect. Oh, what am I doing? I thought I cleared this. Here I'm staring at Praesepe. I need to clear this. Okay, that's good though, because the first image wouldn't have been right. Alright. Let's see if we have any antennae galaxies here. They might be there. We gotta get the levels set first. Let's do this. And then do this. Yeah, we're too close to the moon.
Yeah, there they are though.
Yeah, they're right there. But we're really close to the moon right now. And it didn't lock on properly with the guider, so I'm going to clear that. And probably have to clear this one too. JSCO, what's the name of this song, please? I don't know how long ago you asked that question. What was the last song we heard? It was probably this song here. If it's this song you're talking about, it's called Metamorphosis. If it's this song you're talking about, it's called Write, WRITEUYOU. Okay, now we're guiding right. You get some color out of that though, look. Okay, well the previous song was Metamorphosis. By whom? Oh man, I don't know. Let me go back and see. No title, no name given, I'm sorry. The one with the piano. Look at this, Daryl. This is actually pretty sharp. Alright, so let's even this out here. Okay.
Y'all have probably seen this in images before, folks. I just posted a link in chat to famous Hubble image of the antenna.
Okay. Well, let's zoom in on this and see. Okay, this is 5 stacked. Let's see what we got. Again, it's a full moon. Not expecting miracles here. It's not optimally placed. That's two colliding galaxies, though.
Yep.
Yeah.
Shows up better than I expected on such a bright night.
Yeah. Wait till we have a moon-free night. This is gonna be stunning. Yeah. Okay. Let's do this. Process that and do a color correction. And get rid of the green.
When you look either at that Hubble image, or B, what Marc is showing right now, it's 2 galaxies interacting with each other.
Yeah.
And you're not even seeing the fainter parts, the actual so-called antennae, which are 2 long trails extending way out from the actual central core of the 2 galaxies.
About this size right here, guys. About like that. Just about. I'm having trouble drawing a circle, but it's about like that. And we'll see that a lot better when we actually get the dark sky night that we want. But that's pretty. You know, I'll save it anyway. Why not?
Alright.
I'll save it.
Here's a different picture that shows the 2 antennae. Way out in the outskirts.
We'll be able to see all that once I
you can see how big they really are.
Yeah. I can't see if I spelled that right. It doesn't look like I did. Alright, antenna galaxies. Alright, there we go. Okay, we got 11 stacked here. We'll go a little bit more. The guiding is good, which is nice. And these little guys are right there. You know, and they're actually 91 million light years away, which is really quite a distance. Yep. Neato. So somewhere 91 million light years away, the light we're seeing coming to us now from these galaxies left 30 million years before the dinosaurs died. And we're seeing it now. So we got 15 stacked. We'll go. Now we're not doing. This is only a 25-second exposure. When the moon's not out, we will sometimes do 55-second or more exposures, and we would actually capture a lot more detail than you see. You'd see the ringtails basically of these galaxies without any problem. You can almost see them now. They're just not quite visible.
Whoops, I just sent you a link by mistake.
You did?
Just says, yeah, it just says YouTube. There is the link I meant to send. It's that image of the Antennae galaxies that shows the tails.
Okay.
If you want to show it, you don't have to.
No, that's fine. Yeah, that's good.
There you go.
Well, they don't see that yet, so I have to show them.
Oh.
This is actually what we're taking a picture of, guys, right here. We're showing you this. That's the thing we're looking at right there. Okay, and these are the antennae. And these two galaxies have already passed through each other probably one or more times, or, you know, because they left these trails, so they've done this already. They've been doing this dance. But when we have a nice dark sky, we'll be able to see something like this. It'll be pretty cool. That's cool.
Pretty picture.
Yeah. Okay, well, we got 20 stacked here. And again, we're in moonlight, so it's not the best, but we'll get 21 and we'll pause it. Here we go.
Yeah, this will be one to come back to on a dark night.
Oh, yes. Now that it's a viable object. And it's actually still well before the southern meridian, so it's not even as high in the sky as it would normally be.
Yep.
I was just impatient. I wanted to see it.
Well, glad you did.
Okay. So we'll be back to that. We'll be back right after these rotations. Okay, let's see what we got now. Well, we're going on almost 1 a.m. Yeah, look how close to the moon we are, guys.
Yeah.
And to actually be able to see it, holy jeez, that's something else. Let's see right now, though. Yeah, it's not gonna. Yeah, we cannot get to this yet.
Thank you, Izabela. Oh, that's cool. See other galaxies in the field too.
Uh-huh. Cool.
Thank you, Izabela. So you're winding down? What are you looking for next?
I was trying to see how far down M13 was, and it's substantially far down.
Yeah.
But
Pretty early for Hercules. Hercules, yeah.
Hercules. What movie was that? Come on, someone knows out there.
You got me.
It's Eddie Murphy. I just yawned. Sorry.
It's okay. I'm going to start yarning here in a little bit.
Okay.
You going to call it a night soon?
Yeah, I'm
Toward
probably.
1 a.m. there.
Yeah, because we gotta wait for the moon.
Yeah.
We need a few more days without the moon in our way, guys. That's all. But let's see. Yeah, we're not gonna be able to see that too well. It's galaxy season, and when the moon out, it just says, "Ha ha ha ha! Not for you. No galaxies for you." You know. So we know we can't keep any of these. All right. Well. All right. I will. I will say that tonight. At this point, we'll call it. This was a great night. We had a good time. So I'm all right with shutting down for now because we actually had a chance to capture some really beautiful clusters, and it was really about clusters tonight. I would just get frustrated trying to find galaxies right now because then they'd be like much worse looking than they could be. You know what I mean?
Yeah.
So.
Well, actually, where we just were there at the Antennae, M104 Sombrero was just above it.
Yeah. Well, we'll wait for another night.
Wait for the dark of the moon for that.
Yes, exactly.
Okay.
All right,
well,
guys.
Thank you for having me, Marc. Had
Absolutely.
fun tonight.
It was wonderful.
Cool stream.
Yeah.
Thanks for coming, everybody.
Yeah, thank you, guys. And if you stick around for another year, we'll be so happy to have you again. Join us. And you know what? We're actually getting better memberships. We're gonna start doing some kind of marketing to try and bring more people to the stream, and that will allow us to get better equipment and even more telescopes in other locations. And that's really what this is all about, is trying to bring astronomy to the masses. So until tomorrow or the next night, probably we should wait probably 3 or 4 nights now. But I don't know, if it's clear out there, I just can't help it.
Yeah.
I don't know. Go figure. Anyway, guys, you have a good night, and we will talk again soon. So we'll see you later.
Good night, everybody.
Good night.